Monitoring with InstaGENI and GEMINI. So the session that we're doing this afternoon is going to be mostly a description of what InstaGENI is, what you can do with it, how you can use GEMINI to monitor your slices, and then we are doing a hands-on tutorial on Thursday morning. And I'd actually like to remind those of you who are registered for the Thursday morning tutorial that you should have been sent instructions on how to apply for an account to use that tutorial. And you will need an account for the tutorial, so that we don't spend all our time setting up accounts. To register for the tutorial, please do go ahead and follow those instructions and get an account created. So I'm going to spend the first part of this talk kind of giving you a description of what it is that InstaGENI is. So it's a collaborative effort between 4 institutions. HP is the lead on it. They are the hardware vendor. University of Utah and Planet Lab are providing software that runs it, and I'll be describing all this stuff in just a second. And then Northwestern is handling a bunch of the logistics and actually getting network connections to these different to the different places where these racks are installed. So so an InstaGENI rack is, as you may know, there are 2 main rack efforts in the GENI project, which are intended to get compute and network resources onto a bunch of different campuses, and then make those available to experimenters such as yourself. So the design space that the InstaGENI racks go for is to make them relatively easy to deploy and relatively cheap so that we can deploy a lot of them. So under funding from the NSF through the GENI project office, we're deploying approximately 30 of these things at campuses around the country. And there are a number of other campuses who are actually just going off and buying their own and sticking them on their campus. It is hardware that is kind of intended to be repurposed between different uses. So in particular, it's intended to allow some experimenters to use bare metal on PCs, or other ones to use virtual machine. And because this is a facility for doing network experimentation, it's designed for flexible networking more so than high performance networking. So each machine in the rack has several different interfaces that can be repurposed between different slices that are using it at the same time. The basic software provisioning on the rack are that the Emulab software, which has been extended to port GENI through Proto-GENI, does bare metal provisioning. So if you have an experiment that you want to run that requires that you have a PC all to yourself, then you can get this. And the reasons you might want this are if you need low-level access to the hardware, such as doing network experiments that require, say, particular network drivers, or more commonly, if you need to get some level of fidelity for your experiment. So if you need to make sure that the numbers that you're gathering for your paper are not affected by other people who are using those same resources at the same time, then you can ask for a bare metal machine and know that you're not being affected by other users. So sort of inside of that, we can also, because these racks have 5 physical nodes in the mean, so obviously we couldn't support very many experimenters if we were going to give every experimenter their own physical machine all the time. So we also have one working and one in progress way of slicing individual physical machines into many virtual machines. So the Emulab software has a container-based solution for providing something like a virtual machine on the rack, and we're also using the Planet Lab software as well on some of the nodes, so that it'll come up and look like Planet Lab nodes. I am gonna, I think, skip through some of the details and just kind of show you this is because really what I want to get to is I want to get to showing you the actual interface to using these things. But the racks have five, as I said, 5 physical machines in the bottom. They have a network switch that provides both network connectivity in the rack and is also used to provide connectivity off the rack. So most of these racks are going to be connected to things like the OpenFlow Mesoscale backbone. They are also, many of them, connected services like the Internet to Ion service or other circuit services. In some cases, they're connected to special resources that belong to the campus. In some cases, they're used to connect to sort of special off-campus network connectivity. So for example, the one that's at Northwestern has some connectivity into Starlight through this switch. The rack has a lot of empty space in it. Part of the goal of that empty space is that some campuses are choosing to put unusual hardware of their own in that space. So for example, the one that we have at University of Utah, tonight at the demo session, you'll see demonstrations from a project from Japan that has a testbed that is mostly in Japan, but there's one node in Utah that lives in our InstaGENI rack. So in some cases, there'll be kind of strange, interesting things to use in the rack. I'll skip to the details of the topology. This is a picture of what one actually looks like. This is the one, actually I think the left one may be a DBN and the right one might be a Utah. And now I'm just gonna show you where they are. So we currently have, so as I said, the plan is we've got 32 of these things, so you can get some really interesting geographic diversity. At this point, we have 6 of them up. Some of them are still pending final testing from the GENI project office, but we have one at the University of Utah, we have one at Northwestern, we have one at Kettering, one at BBN, one at the University of Kentucky, and one at Georgia Tech. And those are all just about ready for experimenters to use. And there are 3 more that have been delivered that we're going to start setting up as soon as we're done with stuff this week, and a couple more coming up every month. Many of these are connected by various layer 2 infrastructures. You can see most of them are connected into the OpenFlow backbone in the middle. Many of them are also connected to their regional networks. Some of them are reachable through dynamic circuit services. And I think that there is actually a demonstration of that latter capability going on next door in the same session. Okay, well, so I'd like to move on to kind of showing you what this actually looks like to use. But before I do that, are there any questions about kind of what an InstaGENI rack is? No, not at all? Okay. So the tool that I'm going to use is not developed specifically for InstaGENI. It's a general GENI tool. It is particularly tested with the InstaGENI racks, but it ought to work with it ought to work with other racks teams as well. So this is the GENI desktop developed by the University of Kentucky, and you're actually going to hear more later in this session about what you can, the various features of the desktop, but I'll show you some of the basic ones. So the first thing that So the first thing that you'll notice is that it wants to know who issued my GENI account. So in GENI, there are multiple slice authorities that allow people to create accounts and to get the authorization to request resources. And there are, this offers me 3 options. I'm going to use my account that's at the, but to be clear, having a account at any one of those slice authorities enables you to use resources at any one of the InstaGENI racks or any one of the other federated GENI resources. So I'm going to use my account that's created at the University of Utah. And when this comes up, it's going to give me a list. There we go. So this is the list of all the slices that I have already created. And so I can, we'll go back and look at some of these slices later. It also gives me the, it also gives me the ability to create a new slice using the FLAC tool. You guys might have seen this before. We've given tutorials using this tool at previous GECs. And again, this is a generic tool that works not just with InstaGENI racks, but is particularly tested with those. So at the screen, it's asking me which GENI aggregates or collections of resources I want to potentially look at. So the 6 that I have selected are the BBN InstaGENI, the Georgia Tech InstaGENI, essentially the 6 racks that we have up. And so this is going out now, and it's actually requesting from each one of those aggregates, please give me a list of the resources that you have available, and displays them on the map. And you can see it stacks some of them. So if I zoom in a little bit, this is 6 that I was showing you earlier, and I can click on any one of these and ask it to show me about the nodes that are available there. So what I can see, so I'm looking at the moment at the one at the University of Kentucky. It has 2 PCs that are set up in shared mode. It might be kind of hard to see from the back, but it's got a little stacked looking configuration. So these are ones that if I requested these, what I would get are virtual machines that are on a physical machine that's being used by other people at the same time. And you can see from the little green checkbox, these guys are both available. I also have 3 exclusive access nodes, which are PC3 to PC5, and these are ones where I could ask to have them all to myself and run on the bare metal on them. And the little X next to them means that they are currently allocated, probably to a tutorial or demo. And I can dig in and look at more information, such as the links that are on this machine and where they go, and I can do searches. I mean, of course, it won't be found here, but if I want to search for a node that has certain properties, certain amount of RAM, certain CPU, I can do a search through here as well. And if I really want to, all this stuff is none of the things that we're displaying here are actually hard coded in the FLAC tool. They're all shown in this advertisement RSpec, which is this big lovely lump of XML that FLAC is fetching and parsing and displaying for you. So to actually use some resources on an InstaGENI rack, I go ahead and say I want to create a new slice, and we'll call this GEC16. GEC16 demo isn't already a name that's taken. and I'll get a canvas that I can drag nodes onto to actually request them. So on the left here, I have the list of all of the rack aggregates, and I can go to any one of them, say the Utah one, and drag some virtual machines out onto my canvas and interconnect them with links. Let's do something a little more interesting. And so in a minute, when I'm ready, when I click the submit button, I'm actually these 4 virtual machines are actually going to be created for me. I can either use them interactively by logging into them with SSH and loading software, running commands. I can also script my experiment by giving URLs for software that I want to have installed automatically. And I essentially give a URL to a tar file and indicate where I want to have it installed. I can also add an execute service, which is something that's going to run automatically when the machine boots. So I can download the software that I need and have it start when the VM starts. I can choose the operating system that I want to have run on it. I have just a couple choices on this particular aggregate. If I cared which of those physical machines it went to, I could actually pick. I'm not going to. And I can do things like set properties of the links between these. So I can go to this LAN. I can go to this LAN and I can do things like specify IP addresses. I can actually ask for it to be. I can actually ask for it to have artificial traffic shaping constraints put on it. So another thing, so this is going to give me some basic VMs, but of course in many cases when I run an experiment, I actually care about watching what goes on inside my experiment, and this is where the GEMINI tools come in. So my little puzzle piece icon here brings up plugins to this FLAC tool. And in particular, I can say, okay, I would like to use GEMINI extensions, which you'll notice added this node for me. So I'm going to let other speakers later talk a little bit more about GEMINI and how it works. But essentially what this has done is it's added a node to my topology that's going to handle the measurements. And it's actually added some information into my individual nodes that adds some commands to make sure that the measurement starts up on them. And when I'm satisfied that I'm happy with the thing I've drawn, I'll click submit. It asks me if I really want to go out to the Utah GENI rack and install there and instantiate my slice there. And and at this point, it's doing a bunch of things that to a user are incredibly boring. To those of us who develop it, were incredibly hard to develop. But it's actually going out and creating these virtual machines. So to save a little time, this will take maybe, it should take like 2 or 3 minutes. But it's a little bit of time. I'm going to go back and look at so at this point, my virtual machines are booting, essentially. I can go back to this desktop, and I'm going to look at one that a slice that I already made earlier today. In particular, I'm going to look at this GEMINI test. And so what the desktop is doing at this point is, on my behalf, it's going out to the InstaGENI rack here in Utah, and it's talking to that measurement node, and it's making sure that all the measurements are set up on this slice. And as it says, this will take a couple of minutes. because it might need to start some services up, install some measurement software. There's actually another good chance for me to take questions while we're waiting for this. Yeah?
First, an observation. Whoever decided that it was a good idea to have one called Flukes and another one called Flat. I'd like to personally thank them, but I didn't bring a baseball bat with me. So,
I'm going to say Flat came first.
But can you explain the difference between the GENI portal that we saw and the GENI desktop, and other ways that we've also seen people demonstrating how to access GENI? Are these going to continue to exist as separate entities, or is there some reason why they're different?
So they are tools that do some similar things, right? And it's not clear to me whether they will be separate forever or not. I actually don't develop the desktop. Jim, who I would direct this question to, actually just stepped out a minute ago. But you can ask him again when he gives his part of the talk. This desktop was developed in large part to provide an interface to the GEMINI measurement tools, right? So a lot of the stuff that I can do from this view involves looking at real-time measurement data. As you may have noticed, the FLAC topology creation tool is actually embedded in both of them, right? So we designed that in a way to make it relatively easy to pull it into another service that is already getting the user's authentication credentials and use it from either place, right? Oh, hey, Jim, we got a question for you, which is whether the GENI portal being developed by the GPO and the desktop will be separate things forever, or whether there will be an effort to unify them in some way.
There is some talk about unifying them. There was actually discussion this morning about how to unify the different graphic user interfaces. So at some point we sort of expect to see them come together, but at the same time I think each of them brings something different to the table.
So yeah.
I guess one comment, Jim, you can correct me if I'm wrong, but I thought one of the key issues that was being addressed is being able to log in, for instance, at the GENI portal, and then being able to directly go to the GENI desktop if you're interested in instrumentation without having to log in again, as we saw with the GENI desktop. So the GENI portal would basically allow you to set up an environment with your user credential, user certificate, and then move to these trusted tools. So it's more of a seamless experience versus having to, log in again at this different page and basically create more pain for the average user. But I believe that's the direction things are going.
One of the things I'd like to do is integrate for them because they're using InCommon as a way to get in. It's just a nice way of getting in. So that would give you one sort of prevent that just one login.
So it might, it may well always be the case that there are separate tools to do separate tasks like viewing viewing real-time measurement data, right? For the simple reason that developing one tool that fit all of those needs might be unwieldy, right? But to the extent possible, it sounds like there are some efforts to not force you to log into each of them as separate tools. So, excuse me. Yeah. Oh, I'm sorry. Yeah.
So it looked like you created a node to do the data collection.
Yeah.
Where does it get created?
And again, there are other people in the room who actually can answer this best, but I'll give it a shot. Which is, so the way that the way that the GEMINI tools work is that at each aggregate, which roughly corresponds to a physical location, a node to control the measurement is allocated there. So in this case, I've got my triangle. You may have noticed I drew a slightly different topology in the slice that I created live than the one that I created earlier. But in this case, I've got my triangle, which is the machines that I'm actually running some experiment on. And I've got this other little, I believe it's called a global node, that's separate, so that it can collect monitoring data without impacting my experiment. So there's software that needs to get installed on that thing to pull the other machines for monitoring data. It's going to use some CPU and network bandwidth, et cetera, to collect and some disk space to store that stuff. And so we get stuck in a different virtual machine or a different physical node. And if I created one, if I created a slice, here, let me go ahead and create a slice that uses more than one.
So is it part of the slice, or is it somehow?
It is part of the slice. So it is still under my control as the experimenter. These tools are going to happen to do some special things with it that set up the monitoring for me, but I can log into it and configure it and control it just the same as I control anything else. But it's and it's not from the perspective of GENI and InstaGENI, it's not special actually, right? I could manually set that thing up myself if I wanted to without using these tools, right? But the tools are there to do it for me. And so if I were to create a slice that had resources on more than one InstaGENI rack, I would get one of these nodes on each rack that is responsible for collecting data from the other nodes in my rack. So if I do this, and then I drag out a machine from Kettering, you'll notice I got all of a sudden this another one appeared as if by magic for me. And then let's say that I also ask for something from Northwestern. I see Northwestern is being used for a demo. Let's go with Georgia Tech. Then I get a measurement node at Georgia Tech as well. And one of the functions of the GENI desktop tool is to aggregate the data that it's getting from both those measurement things and display it as one. I'm going to be bold and click submit. These are our two newest racks that came up yesterday. So we'll see what happens. These have not been heavily exercised yet. Does that answer your question?
So somehow they're synchronized. Like
okay, actually, that's so. Jim, Nasir, Ezra, anyone of you guys going to take? Are the measurements like timestamp synchronized between these?
Well, I mean, most of the instrumented VMs will have clock synchronization, so we do have some degree of certainty that the measurements are, within the bounds of NTP and the underlying physical host. That's about all I can say at this point. I don't know what Kentucky is doing in terms of their measurement collection for the passive measurements.
Okay. So the answer is, so in case folks in the back are having trouble hearing these answers, the upshot is that the clocks on all of these machines are synchronized by NTP. So the timestamps that we get for measurements are somewhat synchronized, right? They may not be good, so within milliseconds or so, right? So you're so there are some kind, that's good enough for some purposes, right? They may not be good enough for, you can get like an estimate of one way delay or that kind of thing from that synchronization.
They should be time synchronized because they're using the time clock for on-offs on the certain machines.
Right. So each of these racks essentially has a local NTP server that all the machines in the rack synchronize to.
So can this also be used for closed loop control?
It's also used for closed loop control. Can you give me more of an example of what you're thinking of?
Well, so if you're collecting this data and analyzing it and using it for adaptations somehow.
Yeah. I see. Yes, right? I don't know that we have any specific examples of people using the measurement data in real time to control. I mean, I've done some work like that, but that far predates InstaGENI. I mean, Nasir, how long would you say it takes measurements to make their way to from the nodes to the global nodes to the desktop? What's the approximate delay there?
The measurement collected on the measurement computers is before the machines every 5 seconds. So
Okay.
that's the frequency. And the rendering of the data is also done on the computers. So.
I would add to that, we're going to show up in a little bit how we do in Gemini provide an API basically to read measurements in real time and control it. And if you want to write your own script that actually control the measurements, or you want to do it graphically via graphical user interface, and that's kind of coming up after this talk, I guess, after Robert finish.
So the tools that are being displayed here are ones that are essentially, they are ones that sort of you as a user could build yourself. These guys have built them so that you don't have to. But if your experiment wanted to do some kind of real-time reporting of data that was not collected by part of these, or something, or to a different location or a different format, right? Then with more work, of course, you can also do that kind of stuff yourself. Any other questions? These are great. So, yeah, please.
I noticed you didn't draw a link between the two racks.
Excellent. Good
Is
eyes.
there a reason why?
So, the reason why is that, so we currently have essentially 3 ways of interconnecting these racks, right? In general, the way that, many of them are on the OpenFlow mesoscale backbone. These two have not had their OpenFlow support configured yet. So that's one dynamic way of connecting them. Another dynamic way of connecting them are through some of the circuit services, particularly the ones offered by Internet 2. And that service is being provided by a different aggregate. So essentially what you get are these aggregates representing the racks that are at different physical locations, and then another one that provides connectivity between each of them through dynamic circuits. That aggregate is been developed, and Internet 2 has agreed to adopt it and run it as a service. It's not in production yet. A third way to connect them, which actually I could have done, but I didn't, is that we can also set up tunnels across the commodity internet, so you get something that pretends to be a layer 2 device, but is really tunneling over IP, so it's not providing you any performance guarantees, and you might see some other effects from that. Though, as Ezra has been discovering the last couple of days, there are some bugs with this. And then the last one that we have done in some sites are, let's see if it's going to let me interact with this or not. Yep. So in some cases, so all of this dynamic stuff that I've just described, right, the tunneling and the circuit setup and the OpenFlow setup are all the dynamic stuff is great, but sometimes what is easy to get are to get your campus networking people and your regional networking people to provide you a VLAN from point A to point B. And so, and this is, and so we actually have the shared VLAN notion. So if I wanted to attach these nodes to some VLAN that runs to another location, but is going to be, but is essentially set up statically and is going to be shared by a bunch of people, I also have support for requesting that as well. And I get a list of them. This one, the only one that is configured is the one, is the mesoscale OpenFlow VLAN. As you can see, as I mentioned earlier, it's not, we don't actually have that set up on these two racks yet. So the goal, right, is that, and I believe that this has been set as a goal for the next GEC, is to get, so all these things are collectively called stitching between multiple sites, is to get the stitching stuff ironed out well enough that somebody can just draw a line in this tool and not worry about which one of those things is happening, and have it set up automatically. Like I said, I believe that they're doing a demo and discussion of stitching actually right on the other side of this partition right now. So that's something that's been kind of a while in coming, but it is you know, supposed to be around and working for the next GEC. Yeah, because that's obviously an important thing. Now, of course, all of these guys are connected to the commodity internet, so they can talk to each other over IP, over whatever their campus network is already, right? So that is already possible. And this actually brings up something else that I did not show, which is, where'd it go? Actually, I'm going to have to make a new slice to do this, sorry. So that slice that I created, that I just created, is done creating, and so my ability to, I don't have as much ability to modify it. Let's see. There we go. So one of the things that I can do is, I lost my checkbox. Here we go. So, so, you know, on many campuses, public IP addresses are a scarce resource. And so by default, if I don't ask, each of these machines is going to get a private IP address and be natted to the outside world. So I can still fetch stuff from outside, but I can't really run a service on it. One of the features of InstaGENI is that we treat IP addresses as a reservable resource. So if what I need is for one or more than one of the machines in my slice to have a publicly routable IP address so that I can run a web server on it, or I can, or for example, we use this for the measurement control nodes in GEMINI because they need to communicate with each other. I can go ahead and check this box, and it will actually request a publicly routable IP address if there are any still available at that site. And the number of publicly available addresses varies a lot by site. You know, in Utah, we have an entire Class C for our rack. There are some other ones that have given us, 32 addresses or whatever. So it's not the default, because in some cases, in some places, it's a scarce resource. So that was a very long question to a very, very long answer to a very simple question. Does that get at what you were wanting to learn?
Yep. I'm curious how you interact with OpenFlow paths, but that's probably going too far.
Let me say a little bit here. So, so the way that these racks work is the management of the actual PCs and virtual machines and non-OpenFlow links is managed by the GENI software. They also have one VLAN that goes out to, and most of them have this, not all of them, but have one VLAN that goes out to the OpenFlow mesoscale backbone, that is managed through Foam and FlowVisor, which are the standard aggregate managers for OpenFlow. So essentially what you need to do if you want to use OpenFlow is come to the Proto-GENI software that is running on there and request the resources, and then go talk to Foam and request the flow space. So it's a little bit of extra work. On the other hand, if you're going to use OpenFlow, you're going to be doing a lot of work. Okay, I think at this point I would like to go ahead and oh, yeah, sorry, one more question, and then I'll turn it over to Jim to talk about it.
I don't know if this is pertinent to this conversation, but if I have a GENI rack and I have one of the machines and I've got so many ports open to it, can I connect any network device to that? I mean, if I had a robot or a...
Yep. So, yeah. So for those in the back, the question is, if you have an InstaGENI rack and you want to connect anything into one of those, any network device into one of those ports, there are kind of two answers to this. So the first answer is that if it is a PC of some type, right, there may be some amount of work, and because we're doing 30 racks, we don't promise to do this for everyone's PC, to make those PCs kind of under GENI control, right? The second answer, which I think goes more to the question you were just asking, is if it's some other weird device, can I connect it? And the answer is yes, the device itself won't be automatically brought under GENI control, but the ability to ask for network connectivity to it will, right? So, so actually, one of the things that we've done here, I have to show you this slice just because it's so crazy and ugly, is that the demo session tonight is actually being run as a slice. And so all of the laptops that are all the ports on the switch and the laptops that are being connected to those ports are actually showing up as devices that slices can be made to, right? But GENI is not controlling people's laptops, but I can say, here's this port I would like, please make me a slice to this port to give me the OpenFlow VLAN to this port or public internet access to this port, or whatever. So Jim, you want to? This is that crazy slices. Oh yeah, you want to grab, and this actually came out the day. This actually came out.
All right, can you hear me? All right. Okay, all we need to do is get this, get you to see the screen. Anything special, Rob?
So I had the thing I had to do on mine was I had to adjust the resolution of my laptop because it's got a retina display that freaked out the email. So
Seems to be flashing.
yeah, I noticed it's there. Go ahead and pop up the display. But you turn on your
Don't worry about that later.
Yep, there you
Okay. All right, great. All right, apologize for that delay there. All right, so let me tell you a little bit about the GENI desktop, which Rob alluded to. And I'm going to start with a little bit of history as to how we got to where we are, so you can sort of understand how we got to this particular interface. We've actually been working with the EmuLab system, which then turned into the Proto-GENI system, which has now basically become InstaGENI racks over the years. So we actually started out and we were doing some research using EmuLab many years ago, and we also started to use it in some of our classes. And one of the things we quickly learned in our classes was that when we were handing out assignments to our students, they could really quickly create a topology, start an experiment, use it. The only problem was that they didn't have the system administration skills to understand where were their packets going, what was the traffic looking like. Their tools were all there, they just didn't know how to use them. So one of the things we decided to do is we needed to add some support into EmuLab, and we actually renamed it to be called EduLab, where it had this extra node. So one of you were asking about this extra node. That's where it came from. We added in this extra node to sort of help the experimenters, our students in particular, be able to get up and running very quickly, understand what the topology looked like, where their data was going, run monitoring tools, and that sort of thing. As time went on, we sort of transitioned along with Proto-GENI. When they went from EmuLab to Proto-GENI, we actually turned this into what we call the InstTools service, and we developed a similar portal to allow you to interact with your experiment and understand where your data was going and monitoring. After that, we teamed up with the group from Indiana University, and they're going to come up and tell you some really interesting developments that they've been doing. They had an entire system that they've been using almost in a commercial basis in the backbone of Internet 2 and other networks as well. We took InstTools, we combined it with originally, if you sort of did the history there, Sonar, and then moving forward, there's several versions there. We combined with them to create the GEMINI measurement and instrumentation measurement service. Again, we changed the interface at that point again, so we had what was called the GEMINI portal. So if you look back through GECs, you'll find that there was some documents describing the GEMINI portal. And what we're describing for you right now is sort of a new interface, which is called the GENI desktop. And the GENI desktop is, again, sort of a new revision of the interface to get at and look at your measurement data that's coming from your experiment. But in addition to that, it actually does some other things. So as Rob already showed you, it has an interface to other tools inside of GENI, like FLAC, where you can actually create your experiment. All right, so he showed you sort of the initial GENI desktop. This is, we'll demonstrate this for you in just a moment and tell you a little bit about the GENI desktop. But one of the things I should tell you about is one of the things we were looking at was if you're going to interact with your slice, you've got all these resources, what's the best way for you to interact with it? We had ways of showing measurements, but we didn't actually have necessarily a complete package for interacting with nodes, logging into them, accessing them, controlling them. How do you do that? And what should that abstraction be? All right, so we thought about this for a while, and we actually came up with the sort of problem statements that we'd like to be able to actually visualize the slice and see it, and it turned out that after having used it for a while, we realized that we actually like to look at the slice in several different formats, and we'll show you some of them. The other thing is that you should be able to apply operations to the resources that you've gotten inside of your slice, and that should be a really seamless and straightforward operation. All right, so one of the things that we realized was that sort of a common requirement in all of this was that what you'd really like to do is select a whole bunch of resources in your slice and apply some operation to them. Okay, and you'd really like some sort of unified way of doing that. So what we've done in the GENI desktop abstraction is actually sort of mimic or model our interface much after a common interface that you've all come to know and love, which is basically a file browser. If you use a file browser, you go to your file browser, it lists all your files, and you can go in and select a whole bunch of files, and you can apply an operation to them. You can copy those files into another directory, you can delete those files, you can move them to other locations, and it's a pretty well-known interface. Well, the similar interface in some ways applies to the GENI desktop. That is, you can go in, you can select a whole bunch of nodes, and then you can apply an operation to them. So that's basically how the GENI desktop works. All right, so in addition to that, it actually has several other features which I've sort of listed here. You probably can't read them from the back of the room, it's too small. We did try to integrate with some of the other GENI tools in FLAC to make it seamless for you to log into the GENI desktop and from there straight into FLAC, so sort of a single sign-on. We'd also like to provide access to all of your slices, so a listing service for all of your slices. It also provides basically a windowing system so that you can pop up some of your measurement graphs, take them away, move them around on the screen. That was another goal for us to do. And then to provide sort of different types of views. So we talked here about logical, geographic, and list view. I'll mention that in just a moment. You can actually use the GENI desktop whether you use the GEMINI instrumentation or not. So you don't have to have instrumentized your slice. So if you don't really want to go to all of that, you can use the GENI desktop. Some of the features that you would get if you had instrumentized it will not be available to you, but you can still do that. All right, and if you have instrumentized your slice, you can actually then quickly get at measurement data that's coming both in passive form or active measurements. And the team from IU will be telling you a little bit about how to do active measurements in just a bit. And it allows you also to run commands, to SSH into nodes, and to upload and copy files onto your nodes as well. If the data, and one of the goals was to try to make data, measurement data, very rapidly available to you, easily available, so that the things that you use the most are really at your fingertips. If that isn't good enough for you, though, we wanted the ability for you to drill down and be able to find more detailed information. So that's there as well. So if you can't find what you like at your fingertips, there is the ability for you to drill down and find more detailed information. All right. So we talked about a couple different things here. First of all is when we initialize the GENI desktop, it's initialized in 2 phases. And the first phase is basically to add in this extra node, which we call the global node. And the reason for the global node is that it provides a way for us to get to the measurement points, the other resources inside of your experiment. It helps with some of the visualization tools. It provides SSH access in. It's basically acting in many ways as a proxy. So to get sort of basic services of the GENI desktop, you at least have to do that. This is not yet instrumentized your slice. We haven't loaded all the software on to do monitoring. We haven't loaded on the software to do displaying of real live traffic graphs or any of that sort of thing. All it's done is sort of provided a mechanism for us to get into your slice and for us to give you access to your nodes. If you decide, you can then go on to the next step, which is to actually instrumentize your slice. And that's actually a verb we use here, to instrumentize your slice. And that adds in the software that will, in fact, give you measurement data, live graphs from the experiment as you run them. And you can go in and configure active measurements as well. So those are sort of the 2 phases to the GENI desktop. All right, so at this point, I'm going to ask Usama bin Nasir, who's done a lot of development of this, to sort of come up here and talk about it. What I'd like to do is show you 3 sort of views of this. One is what we call the logical view. That gives you a logical view of your topology. And that is very useful in general for just sort of seeing where your nodes are, how they're connected together. But in many cases, you may also want to know, well, where are they located on the map? Did I get a resource in Utah? Did I get one in Kentucky? Did I get one in Atlanta? Where did I get these different resources? And then there's the logical view. Oh, logical. That's supposed to be the list view. Let's change that. It's the list view. And the list view gives you a listing of all your resources. And as a result of having that list view, you can just sort of look at each of those resources in more detail. And so it turns out that that actually is 3 different ways that each of them has different advantages. Okay, the list view turns out to be very useful, particularly if you have a very large topology. And we'll try to show you some of that in just a minute. Okay, so sorry, I thought I was almost done there. But we're going to have to do a quick switch here. And Nasir will take you through some of the interactions that you can do in the GENI desktop. And I will sort of try to talk and narrate while he drives. So the GENI desktop, you've already seen Rob used it. The very entry page you come to, it says log in. And we've tried to make that relatively simple by you then picking where you received your credentials from. Once you've selected that, you are then redirected to log into your home machine. Once that's done, then we pull the information we need to let you into all other GENI resources at that point. So,
project takes a time.
Okay.
It's where we input.
All right. So there, you've seen the login process there.
and how you actually get into GENI. So where we're going to start out is with once you're logged in, you actually see a list of all the slices that you've created. And if you haven't created any slices, at that point you would actually be able to use the flat tool to go off, create slices. Then you can come back to this page, the GENI desktop page, and you can refresh the page. And once you've refreshed it, you'll be able to see the slices there. All right, so what's the story? Oh, there it is. Okay. All right. So once you've logged in, you'll land on this page here, which is our list of slice pages. And in the first box here, where it's for those of you in the back where you can't read these small words, it says here's your available slices, and there's 3 of them listed here under this current user. And if that's not good enough, then there's a button down there that says flat, and you can go ahead. If you click that, you go through the experiment that Rob just showed you in terms of creating a slice. And there's also a log out button, of course, if you want to log out of the GENI desktop. All right, so what we're going to do is we're going to start where Rob left off. He had created a slice, but had not yet actually sort of looked at it using the GENI desktop. So after the slice is created in flat, you'd come back to the GENI desktop, and it would appear here. And now you would click on it here. And what the first thing it's going to do is it's going to try to find out information about, go ahead and do that, that takes a moment. It's going to try to find out information about the slice. And the first thing it will find out is that, oh, this slice has been created, but it did not go through that first initialization step. So at this point, it's checking with the various component managers and aggregate managers out there to find out what status this slice is in. It should come back in just a moment and start to say, well, this slice is not, actually it finds out that it's not initialized and immediately begins that first initialization phase so that it can be used with the GENI desktop. So this usually takes a minute or two, not terribly long. It usually goes along pretty quickly. Okay. This one should be there in a second.
It's the northwestern rack, so.
Oh, I see. Okay. All right. So you want to switch to another one?
Yeah. Sorry.
Okay. So to move things along here, that usually comes back in a couple minutes. Once it finds out that the slice it exists and it does that first initialization, at that point it will actually bring you to the GENI desktop. So. All right, so it noticed here that the instrumentation is complete. So at this point, this one has actually gone through both phases. I really kind of like, if we'd love to come back and go back to the instrumentize of the other one in just a moment.
Not sure this might not come.
Okay, all right. So at this point, this one actually has been through both phases here. It's already been instrumentized. So what we're seeing right now is what we call the topology view. This shows a little simple 3-node topology, plus there's an InstaGENI, a global node also added into the service here. Why don't you close down this topology view and bring up the geographic view. So if you look at the geographic view, it actually shows you your nodes and where they're roughly located. Now, since these nodes are all located on the same InstaGENI rack, it exploded them out because otherwise they'd all be piled on top of each other and you wouldn't be able to see anything. Right? But these are actually loaded onto the InstaGENI rack at the University of Kentucky. So this one gives you sort of a map view of where you are. So these are basically identical topologies, just viewed in different ways. A third view, I'm going to close this one, is the list view. And the list view actually pops up a list of all your resources here inside of your rack. Okay, and so each of those views is valuable in a different way. Let's go back to the topology view. It's okay. All right, so what you can do now in the topology view is that you can select a node in the topology view. And once you select that node, you'll note here that it actually also appears in the other view. It gets highlighted in the other view. So all the views are in fact linked together. So if you select VM C in this case, it highlights it over there also in the list view. You can Once you've selected those views, you can then apply an operation to them. So up on the left-hand side here, we have, well, you can show them the settings buttons. The settings button shows you, oh, that's the launcher, okay. Settings button shows you a set of different operations that we have loaded in. The system's extensible. You can add in additional operations to it. But right now we've got an SSH operation. We have a run command operation and a file upload operation that have been turned on. And then we've also turned on a module which shows the GEMINI mobile node information and GEMINI graph. So we'll take you through some of these sort of quickly. So if you close that and bring up the launcher for SSH. All right, so we can bring up the SSH launcher here. And what the basic idea is that you go to the topology view or the list view here. And at this point, what you do is select a node, and then you can click on the operation here. So you apply an operation. And in this case, it's now going to try to log us into that particular machine. And in this case, it automatically logged us in and created a new tab for us to get into that machine. So to get into any node in the system, you just simply click on it, and you say SSH, and you can quickly log in. And then you can begin typing into that particular tab. So if you go back to the GENI desktop, another feature that you can do is if you have a topology with several nodes, let's say you select the other two nodes right now. Okay, that's fine. And we can again go to Open SSH. And in this case, when you click on it, it will actually find those nodes, find out where their IP address is and their location is, and it will immediately create multiple tabs here and log into several machines at once. So if you're working on an experiment, many times you really want to be able to get at a whole bunch of machines. You just want to point at them, say log me in, and the next thing you know, you have several tabs open and you can SSH into them. All right, so this turns out to be very useful. We use this quite a bit. All right, so you can maybe perhaps close that one down and bring up the run command. So another module we've built for the GEMINI desktop is the ability for you to run a command across multiple nodes. You maybe don't want to necessarily log into all of those nodes, but you'd like to run a command across multiple nodes. So let's say that you select, let me go ahead and select all three of them. Okay. You can bring up a run command. You can say, I'd like to select the set of nodes that I would like to run on. And so by clicking on that set selection box there, it set the list of nodes to run on to the things that you most recently clicked. So again, think of file browser. You select all the nodes that you want, then you go and you collect an operation. In this case, you might type something, okay, you can, spin ifconfig is what he's typing for those of you in the back. And if you hit the run command now, at this point, what it will actually do is pop up some additional windows here. Okay. And it's bringing up a window now with and pushing out to all the machines the command that you just issued. It's sending out to the ones that you selected. And you're getting back an unreadable here because he's got the fonts are wrong. But otherwise, you see the results here from each of those three machines, what the ifconfig command came back with. So you can actually launch a command on a whole bunch of machines all at the same time. Okay. Yeah, that doesn't show up so well on this one. All right. So moving along here. We also have another launcher, which is called our file upload. And we should bring that up here and show you a little bit about how that works. So another thing that you often want to do is you'd like to load software onto your nodes. So again, using this interface here, you could select the nodes that you'd like to use. And you can again hit the set selection over there, which will identify which nodes you want to copy data to. And then we've actually this interface has changed over time. We initially said, okay, I'd like to upload a file from my local machine to this set of nodes. And we pick out a file and then try to upload it. We actually realized that we were doing this over and over and over. And so we actually decided to build in a concept of what we call file sets. So in the middle of this box, you'll note that there's actually a middle area here. And what you can do is you can actually upload from your local machine to the portal itself, the GENI, well, it was called the portal. It's now the GEMINI desktop. You can now upload to the GEMINI desktop a set of files that you're planning to use over and over in many of your different slices. So you can copy them from here. They then appear and move into this node here. So I don't know what you were doing. I wasn't watching. Did you just upload? Okay, so he went into this window, browsed his own file sets, much like you'd upload something to through a web browser. It moved it now to the portal. And once it's on the GENI desktop, from there it will be saved, and you can then upload it any number of times, any number of slices that you may have. So from there, you now can set the selection of nodes that you'd like to do, and you say upload it to this, and you can see that it's starting to copy it to them, and as it copies to each one of those nodes, it turns it green to identify the fact that it's been placed onto those nodes. So, yeah. Okay, so there's this file, bigtopo.final. It was actually copied there very quickly. So, we've been using a relatively small topology here to show you this, and we'll show you a little bit larger topology in just a minute. But let's finish off with some of the other tools. All right, so in terms of action, this is just sort of interacting. These things come for free in that first initialization phase. If you then click the Instrumentize button, that takes a little while. It goes off and has to load a lot of software on it. Okay, so this other one is done now. There's an Instrumentize button here, a little, I guess it's a cello or violin. And you instrumentize your system, you click on that, and it will pop up a window that says it's instrumentizing. And depending on the size of your topology, this will take some amount of time for it to go ahead and instrumentize. All right, once that's done, you have a lot of measurement software that's been loaded on there, and you can then use that to see your topology, see what's going on. So let's go back to the other one. What? Back there? Okay. All right, so why don't you bring up first of all, bring up the graphs module. Okay. So each of these modules, by the way, we're slowly changing sort of the look and feel a little bit of this, but basically each of the modules, you can almost think of them as sort of a drop-down menu, and when you click on it, you have some options there. So here, we might select these, well, we can select one node, and then, now over here on the right-hand side, we now have several different graphs that we can say we'd like to see the traffic graphs on those. So we selected CPU graph, ICMP traffic, and IP traffic. So if you said add graphs with title here, what this will do is actually create a window here for you that has those three graphs. These are now, well, you actually clicked a couple of those here. Blip memory and blip memory tree. So Gash Indiana will tell you a little bit more about those graphs. These are being generated every 5 seconds, and so you can actually see them being updated live. If you mouse over them, it gives you a much larger view of the graph data that's coming back. You can move these around on the screen. You can resize them if you don't like the way that's actually being shown there. You can actually resize the graphs.
Bring it up in a different tab.
You can bring it in a different tab. So much like a windowing system, if you want to get rid of it, there's an X up there. You can X out of it. And on the bottom, we actually have something more like a taskbar. And again, you can iconify your windows and open them or close them. So it's basically almost like a windowing system inside of your browser to interact with the GENI desktop. All right, so that was a couple of the graphs. And these are ones that you frequently use. TCP traffic, IP traffic, UDP traffic, ICMP, those sorts of things. All right, if you want to drill down deeper, there's another module we added which will allow you to go to the measurement node that's actually collecting all of this, called the global node. And you can actually say, let's open a live view of the global node where all this data is being collected. So if you do that, it actually brings you to a web interface on that global node that will give you all the information that we're capturing there. So you can see here, this is actually a list of all the graphs that are being stored and captured there. On the left-hand side, we have a lot of different options. And one of the things that we captured that we don't make readily available to you, but you'd have to go to the global node, you can see information about tables. So you can see all the processes running on the system, all the modules loaded there. You can see what the routing table currently looks like, your IP addresses, your ARP tables. All of that information is also available on the global node. Okay. There's another feature which we've had in there for a little while where you can actually, if you want to actually get into any one of the nodes and do something more detailed, like look at the actual packets that are going on, you can click on Wireshark here, and this will actually bring up Wireshark in an Xterm and actually allow you to do packet captures in real time on the system itself. So if you really, really, really want to drill down, you can get down to the packet level. Okay? And this will actually bring up an X window through your browser with the Wireshark interface. and let you do that. So that may take a little longer than we.
Java changed its plugin.
You just click on that, it starts it up. No, okay. Well, no, it's coming up. I want to move along so we have some time for our colleagues here. One recent feature that we added to the system, if you look at the very top of the thing here, we have a thing called GEMINI Notes. All of this stuff is actually done in a Drupal interface. So if you want to actually edit these web pages or keep track of your experiment, you can do that. So you can actually come along here and you can add information or edit information about your experiment. You click on the edit button, it pops up a window with you to be able to fill in fields like what your hypothesis is, what you thought the expected outcome is, what the test is that you're going to run, and you can add that all into your experiment here, and it would keep it as part of the global nodes information. And when the system's backed up, this is actually all backed up as well. All right, so this provides a sort of an interface for you. Much of the inspiration actually comes from the GEMINI group, who actually did a lot of this work in sort of their lab wiki idea. All right, so that was sort of a recent addition. All right, let me just sort of close by one of the interfaces that we didn't talk much about was this list view. And actually, it turns out once you have a list view and you have a very large topology, the question is, how do you deal with a 100-node topology or a 200-node topology? It will pop it up here. It gives you a nice graph with tons of little dots on there that you can't hardly see. And it becomes very difficult for you to interact with it. In that case, the list view actually turns out to be very nice. And so what the list view does is it gives you a list of all your resources, but you can filter your resources by doing basically a search on that list of resources. So here's a little bit bigger topology. And if we bring up the list view, you can see that it actually is a big, long list here of this topology. But in the top box here, you could say, for example, if I'm interested in all the nodes that are listed as source nodes, that start out with SRC, it will simply immediately limit your list down to them, and then you can select those and only apply the operation just to that small subset. Or if you want to apply it to the list, the nodes that you've listed as routers, for example, you can quickly narrow it down. And you'll note also that it changed it in the topological view here, so you can see exactly where they are. Where did they appear in the topology? All right, so thank you for your, I guess I should ask for any questions. I kind of moved along quickly. Yeah.
Can this work on raw nodes or just virtual machines?
Yeah, so that's an interesting question. The answer is yes, it's designed to work with raw nodes. Much of this is relatively new yet, so there are certain versions of the operating system that run on raw nodes that we are not compatible with yet. So if you raced out today and tried it, you might bump into some problems. Any other questions? Okay. At this point, we're going to turn it over to the folks from Indiana.
So as Jim mentioned, they're also integrated with GEMINI's ability to do active measurements, and we're working on a framework called Blip, where we can have an extensible framework for adding new active measurements and configuring them and being able to display them through the exact same desktop that you just saw now. So Ahmed's going to bring up the interfaces for configuring the active measurements, so you can take a look at how that's done and how the active measurements currently show up in the desktop. And then if there's enough time, we hope to look at some of the details sort of under the hood of GEMINI and talk about some of the services that run in the background. And Matt is planning on talking about some of the Blip specifics in particular, so you can get an idea of how you would actually add your own active tests, for instance, and be able to define how those measurements are collected. So let's see if we can get there.
pass the PJ. Yeah, I have it if there's another screen. I lower the resolution as low as I can.
Nasir, did you have a trick to finally get it to display, or did it just take some
Just
time?
wait for it. Seconds.
There it goes. Oh. All right.
All right, so I'm going to start by showing how we can graphically configure active measurements. And then Matt will go more, Matt and Ezra will go more in details what's under the hood, what is, you know, if someone want to programmatically, like write a script to do that instead of doing it in a GUI or something. So we have seen so far how we can get to the GENI desktop. And I just want to show now from that how we can, from that point, how we can start configuring things. And basically what we need to do is, you know, load up the GEMINI global node module. And we just need to open the BS config. Some of you who have attended our tutorial on GEC might have seen this window before. We were using it to control the Bersonar active measurements kind of thing. And the people who are familiar with Bersonar know that it's a big, huge framework for doing active measurements, and it's widely deployed with large networks like Internet 2 and ESNet, and provides a very flexible format for active measurements and generalized format for exchanging data for measurements and be able to analyze it and reason about it. What we have added to that is BLIP, which is a lightweight, more lightweight active measurement framework. Matt's going to talk about it, and I'm just going to show how we can configure it to do a simple test. We just want to do ping between nodes. In our main window here, we actually show our nodes, and we show the Unix URLs for these nodes. If someone want to go write a script to read them or reason about it, but it just put their information here, so it's a pointer to them. And then we show our blip services that running on each of these nodes. We have 3 nodes running, and we have 3 blip services running, and we have what we call the measurement store, which stores our data, and it's blip collect the data and push them to the measurement store, so we can in real time, almost real time, to get the data out of the measurement store. And the delay is like in milliseconds, because that's one of the reasons that we actually have the global node inside the slice. Is you have the place where you store your data is very close to the from where you're collecting your data, so you don't have that much latency or overhead of getting data out the node outside the nodes. So you can still schedule tests, all Bersonar tests. You can still select the node, schedule Bersonar test, iBerf, one-way delay, or ping, or whatever Bersonar provides you. I'm just going to focus this time about blip test. And here it's very simple. Like, you just need to select the node that you want it to run a blip for you, and you run the ping. I already made 2 tests already, and then you just can select add a test or modify a test, and that's going to modify it in real time for you. It's going to push the configuration to blip. Blip is going to reload itself, reconfigure itself, and collect the data based on the criteria you specified here. Simple criteria is like give a text description on what you're testing, and you can select the nodes you are interested in, what you're going to ping to, if it's within your slice, or you can actually add external hosts if you want to just go ping an external slice to make sure an external node that's outside of your slice, and then you just save, and that's going to be saved into UNS, our Unified Information Service, and Blip going to read it from UNS and reconfigure itself. what's the details in there? I think Matt is going to cover them more details. I just want to show how, in a GUI way, we can do this. Once the test is done here, we can go back to our desktop, GENI desktop, and we just can click on the nodes and ask it to show the graphs. And that's all it. Like, we have the show me, I just want to show flip. And just click add, and then I will see the graphs. I selected the wrong nodes. You can see, I think I think all right. And then I can see the graphs here and reason about my data if I want to visualize them. But still, the availability for you to read it via RESTful interface to get the actual data and do some, programmatic analysis of the data, or do statistical analysis about the data. Still, that's an option for you. And from there, I will leave it to Matt, who is going to talk about more details about what's going under the hood. Any questions before?
Okay. So this is going to be a lightning tour of the components we're sort of developing. We're trying to create a very extensible framework with open APIs that's very programmable. So this is kind of a under the hood tour for people who want to do more advanced things, set up their own metrics to monitor. There's three main components. Actually, there's three main components to sort of our back-end framework. And that's Blip, which runs on the hosts and collects data. MS, which is the measurement store. Pure data goes into the measurement store. No metadata, just timestamp and value pairs. And then UNIS, which is the Unified Network Information Service. And UNIS has all kinds of information about the topology of your slice, what services are running in your slice, metadata about the measurements that are being taken. And both the MS and UNIS can be accessed with a REST API. They can be queried, so you can query the MS for which metadata you want, and then go and grab those data from UNIS or from the measurement store and get those graphs if you want. So it's a pretty flexible framework. But what I'm talking about now is going to be mainly about Blip. That's the part that I've been developing, and that's the part that you'll configure to collect the metrics that you want to collect. So what kind of data can Blip collect? Well, it has probes built in for basic host statistics, CPU, memory, network information, all gathered from /proc. And this is all pretty much written in Python. It should run on just about any Linux host. We support certain VM images and stuff, the instrument scripts do, but these actual tools themselves are pretty easy to install. And then, so these different things that Blip collects, we call them probes. So there's different probes for collecting different things. And then we have a generic command line probe that you can configure yourself to basically run a command and then take whatever data that command gives and get that into our framework. And so then since it's all stored in the MS in the same data format, you can easily get graphs or mess with that data however you want to. Another thing Blip is really good at is scheduling when you want to run your probes. So what we've done is developed a way that you can drop in new scheduling methods that are just very simple Python methods. And the method just returns the next time that you want a metric to run. So it can run arbitrary Python code. You could return random amounts of time between running probes if you wanted to do something like that. You could fetch the time from an external source or a database. You could even have the probe do something very sophisticated, or the scheduler do something very sophisticated, like reacting to the data that you're collecting. If something happens with your data, you suddenly want to collect more frequently, you have the scheduler react and start collecting more frequently. So Blip is a framework that allows you to collect whatever data you want via the generic command line probe whenever you want via drop-in scheduling methods. So this is sort of a deep dive example in This is actually a snippet of Blip's configuration file, which is just JSON. And this is a command line probe that will collect a ping measurement. And there's basically 3 things that you have to give it. One is the command to run. I don't know if you can see that, but it's just command : ping-c1 some host name. And then you need to provide a regular expression to extract the data from the output of that command. So that regular expression is designed to extract TTL and round trip time from the ping output. And then you provide what we call event types, which are basically strings that describe those 2 metrics, time to live and round trip time. So eventually we're going to map those event types to descriptions. Like the event type will be a URL that maps to some description of what RTT is. It's round trip time, it's in milliseconds, and then graphing software can automatically fetch that information. So on the left side here, we have our data representation. It's just timestamp value pairs for anything you collect, timestamp value pairs. So your software, if you want to write a graphing plugin or something, or if we want to write a graphing plugin, it only needs to be able to know how to graph timestamp value pairs like this. Metadata, on the other hand, is still something we're nailing down. We have a basic schema for it, but we're sort of trying to nail down exactly how we want that to look. But the metadata, we collect all kinds of metadata about how this metric is being collected so that you can see exactly where your data is coming from. And this is a deeper example of metadata. So this top part, say you have a port description in Unis, like one of the ports on your machine. And then metadata would say, okay, the subject of this data is this port, and it has a hyperlink to the port description. And then the data in the measurement store just has an ID, which maps to the metadata, so that you can see, because since the data is just timestamp value pairs, you want to be able to see what that data is all about. So you can jump from the metadata ID in the measurement store to the metadata description in Unis, and then you can see the actual description of the port, what node it's on, what its capacity is, etc. We have quite a bit of documentation on GitHub and a wiki. We also have documentation about the Unis encoder. Am I supposed to say anything about the Unis encoder? No. Okay. So these slides are actually up on the GENI wiki, so you can grab these links or write them down. Did you want to say anything?
No, I think that was a good overview. I guess before we go, it is right at 5 o'clock, so that's perfect. But we will have a early morning tutorial session on Thursday, 8:30 to 10, I believe, where we'll actually do a more involved instrumentation where people can actually do it with their own accounts, and we'll be demonstrating some of this work in more detail. I'm actually working on putting together a version of the tutorial meant for people who are interested in running a particular type of experiment on an InstaGENI slice. So I'm hoping to get a small group of people who are interested in that to sit down with me and go through all the steps from slice creation to instrumentizing the slice and running an experiment itself, where you actually log in and do something interesting and collect measurement data about that particular experiment. So if anyone's interested in that, please consider getting up early on Thursday to attend that session. So I think that about covers it.
Yep, and there's a feedback questionnaire at that URL.